Hi everyone, in this video we're going to work on finding limits numerically. So we've already looked at graphs and used them to figure out the value of limits, and here the idea would be if we have something we don't know exactly what it looks like, what are some basically technology tricks we could use to help us get an idea of what the limit is. So this first one, our function is e to the h minus 1 over h, and we'd like to know what happens as h goes to 0. So always with limits, the first thing you should try is just, if you plug in 0, is there anything weird going on? Because if not, then you might be done. That might just be telling you that the function is continuous and that that y value is your answer. Here, if we let h go to 0, we're definitely in trouble because the bottom is 0, and in the top we're getting something really close to e to the 0, which is 1 minus 1. So it's a 0 over 0, and these are actually really interesting forms. Anything can happen. So to use technology to just help us get a pretty good idea, you can go through by hand and plug in some numbers really close to 0 for h. But what I'm going to recommend is just going in here into your y equals and then making this whole thing your function. So we want e to the x minus 1 over x. Okay, so that's my function. And then I want to use my table. So if you don't already have it set up this way, I really like having table set to independent ask and dependent auto. That means I'll type in x values and it'll automatically calculate y's. You could also set them both to auto, and then if you do that, this will actually matter. This will be the x value that you start with, and this will be the steps. So this one is set, if I had this to auto, my first x value would be 1.75, and then 2, and then 2.25, and then 2.5. So you can use that sometimes, but for something like this, I really like picking my own x values. Okay, so I'm going to go into my table, and if you have stuff in there, you can just type over it, or you can hit the delete button right here next to your arrow keys to clear them out. So, okay, if I'm interested in what's happening when h is close to 0, I just checked and I can't actually plug in 0, so you want to think carefully about what you want here. I want to see what happens as h gets closer and closer to 0 from the left and closer to 0 from the right. So I kind of have a picture in my head of the x-axis, right, or h-axis, and I want to work my way in towards 0. So you can choose what you want, but you want to kind of build up a pattern. So a really common thing to do would be slightly less than 0 would be negative 0.1. A little closer would be negative 0.01, and even closer would be a 0.001. And similarly on this side, 0.1 is a little ways away from 0. 0.01 is a little less far away, and 0.001 is even better. And then you can just type those in, and you can even do it in that order so that you can really see the pattern. And then 0, and there's our error because it's undefined. Okay, and then as far as showing work goes, you can just show me this. So I got 0.952-ish, 0.995-ish, and then 0.9995. On the other side, I had the 1.005, one more 0 in that one. Here's the 2 zeros, and 1.0517. And again, what you want to look at is if you start from the outsides and work your way in, these are all the y values of that function that's sitting right there, that fraction. Do they appear to be getting close to something specific? And I would say yes, they do. It looks an awful lot like they're getting close to 1. They definitely aren't always going to be a nice integer value like that. So one thing you can try if you're undecided about exactly what to say your estimate is just to take these two closest and average them. Here that would give me my exactly 1, so I think I did well. Okay, and then just to make sure that we're clear on this, this is the kind of h values I would choose if I want to let things get close to 0. But the second one wants me to look at this 5 times the sine of 2 pi y minus pi over e to the y minus 1 minus 1. I want to see what happens as y gets close to 1. So if y is equal to 1, on the bottom I get e to the 0, which is 1, minus 1, which is 0. So that's definitely some sort of undefined. And in the top, I get 5 times the sine of negative pi, which is also 0. So I've got another one of those 0 over 0s. Those are the interesting ones. So to get my calculator to do some of this work for me, I'm going to go in and do 5 sine 2 pi x minus pi over e to the x minus 1 minus 1. It'll only let me use x as a variable, so we just do our best with that. And then I'm going to go back into my table, but I'm going to be very careful to not use the information that I see here. This is making me want to say that it just approaches 0, but that's what happens when y approaches, or x in this case, approaches 0. And I want to know what happens as x approaches 1. So if I want to know really close to 1, I would start at maybe 0.9 and then go 0.99 and 0.999. And on the other side, I could start at 1.1 and inch my way in with a 1.01 and then a 1.001. So I'm going to rebuild this table. Okay, and there's my undefined right in the middle. So this time, let me see if I can copy those in. I have a negative 30.88, negative 31.55, negative 31.43, and then at 1 it's undefined. On the other side is a negative 31.4, negative 31.24, negative 27.94. Okay, so that's what I'm getting. And again, the question is, as you work your way in towards the value you're actually interested in, do you see a pattern? And I would say, once again, it looks like I do see a pattern. This is a great example of where, what am I actually going to say? It's somewhere around 31.4. So you could just say that. You could say out to one decimal place, I think it's about negative 31.4. Or you could average these two and say, I think that the value is going to be about negative 31.415, something like that. So somewhere in between these two should be a good guess, and you can kind of take your pick. This is estimation, so we're just trying to get close. All right, so that's how we would calculate limits numerically. We would go ahead and just plug in numbers really close to the value we're interested in and see what happens. Thanks for watching.